Here is the comprehension. Standard reduction potential E naught values are useful for understanding redox reactions and for selection of suitable oxidants for a particular reaction. E naught of redox reactions is also used to find equilibrium constant. E naught values can also be used to understand the feasibility of a redox reaction. And here is the tabular column for which some half cell reactions and their standard reduction potentials are given. And we know that the more the negative reduction potential, the best reducing agent it is. And the more the positive oxidation potential, the best oxidizing it is. So if we observe, here is the minus 0.49 negative reduction potential. The more the negative reduction potential, the better reducing agent it is. So thus, oxalic acid is one of the good reducing agents among the list given. And also you can see all the other values. It is 2 for this. Reduction potential is highest. So thus, S2O8 2 minus is the best reducing agent. And then we have the order for it. So what are the various questions given? Question number 1. Which one of the following oxidizing agents cannot be used for the quantitative estimation of ferrous nitrate solution? So the given one is ferrous nitrate solution, where ferrous ion can undergo oxidation to give ferric ion. So how to choose which can act as an oxidizing agent? But what is asked is cannot be used. What do you mean by cannot be used? If the oxidizing agent selected should oxidize only ferrous into ferric but not the other ions, because we want to go for the quantitative estimation of ferrous salt, for which purpose the oxidizing agent selected should oxidize only ferrous ion into ferric ion but no other ion, so that the oxidizing agent is involved in bringing about the oxidation of ferrous to ferric but no other reducing agent. So let us begin with A. A is what? Potassium dichromate in the presence of HCl. So here it is the dichromate ion which is used, and also in the presence of HCl, chloride is involved. So if you can go back and check the standard reduction potential values for dichromate and chloride and compare with that of ferrous, what do you find? Here is the dichromate, for which purpose it is 1.38 volts, whereas for chloride we have 1.4. In other words, this dichromate cannot oxidize chloride. Therefore, the potassium dichromate in acidic medium HCl used can bring about the oxidation of ferrous or not. So here it is only 0.77. So thereby it can act as a reducing agent, dichromate can act as oxidizing agent, and no other ion can be oxidized by this, and therefore it is a suitable oxidizing agent. But we are asked to select which cannot be used. Therefore, A is not the right answer. It can be used. And when we go for the option B, we are having KMnO4 in the presence of H2SO4. Now let us see what is the standard reduction potential of permanganate. And once again, this is sulfuric acid. So we have to see that this permanganate can bring about the oxidation of only ferrous to ferric, but not SO4 2 minus. So let us compare the values. So for permanganate we have the standard reduction potential as 1.51 volts. But for sulfate we have 2, it is more. Therefore, it cannot bring about the oxidation of sulfate ion. And this value of 1.51 volts is more than that of 0.77 volts. Therefore, it can oxidize ferrous salt into ferric salt, but not sulfate into S2O8 minus 2. Thus, KMnO4 in the presence of sulfuric acid can also be used as an oxidizing agent for quantitative estimation of ferrous to ferric. So it can be used, but we are asked to select cannot be used. Therefore, this is not the option. The third one is K2Cr2O7 in the presence of dilute sulfuric acid. Once again, potassium dichromate. So here is now potassium dichromate, whose value is 1.38, and once again sulfuric acid 2, in other words sulfate, that is 2. So this being more, potassium dichromate will not oxidize sulfate into S2O8 2 minus, but the value of it 1.38 is more than 0.77. Even in the presence of sulfuric acid, potassium dichromate can be used. Therefore, when we go for potassium dichromate K2Cr2O7 in the presence of sulfuric acid, the potassium dichromate standard reduction potential, which is 1.38, is more than that of ferrous salt to give ferric salt, but sulfate once is 2 volts. Therefore, it cannot bring about the oxidation of sulfate, but can bring about the oxidation of ferrous to ferric. Hence, K2Cr2O7 in the presence of sulfuric acid can be used for quantitative estimation of ferrous salt. Therefore, this is not the answer. So, the only option now left is, what about D? K-4 in the presence of HCl. Now, when we see this K-4 permanganate ion, the standard reduction potential is 1.51 volts, whereas that of chloride ion is 1.4 only. So this is 1.51 volts, whereas for the chloride we have only 1.4. So this being less, potassium permanganate can also oxidize chloride into chlorine. Therefore, during the estimation of ferrous salt, the amount of K-4 consumed is not only for the conversion of ferrous ion into ferric ion, but also can oxidize chloride into chlorine. Therefore, K-4 in the presence of HCl cannot be used for the quantitative estimation of ferrous salt. Hence, D is the answer. So, thus, option D is right.